Welcome to the video on linked lists. There's a chapter 24 and it deals with lists. And we talked about lists before, actually. We've talked about lists when we talked about array lists. And so we're going to be a little bit more generic with the way we implement lists with chapter 24, because this is going to be sort of like a new topic. And so let's take a look. I like the way the author goes about organizing his code here. And so I'm going to pretty much do what he does in his code. I made some changes here and there, and you have the source code for those changes in the link in Blackboard. But what he does first is he doesn't really worry about the implementation of a linked list or a list. Even if I say linked list, that's really being too specific as to how I'm going to implement that list. He starts off by saying, hey, let's work with what the JDK gives you as a generic abstract view of what a collection of items are. And so we're used to collections. I mean, we're used to arrays. We're used to having a data structure that holds multiple values. But even an array forces you to think in terms of indexes. And really what you should start doing is saying, well, the JDK gives us this concept of a collection. Now, a collection of whatever. This E is basically the data type of what you're trying to store inside the collection. If it's a collection of strings, a collection of dogs, what have you, that's how you specify what's inside this collection. Now, think of a collection as just a bunch of things thrown in a bag. You can't get any more abstract as that. How those things are stored inside that bag is immaterial. Eventually, we'll have to worry about how those things are stored. But what he says is, let's come up with this thing called a list. MyList. He likes to put the word my in front of everything so there's no confusion as to what class is his and what class is part of the JDK. So first off, a collection is just this generic bunch of things thrown inside this digital bag. How they're thrown in there, who knows? But as soon as you say, well, let's create a list, what you're doing in that bag is you're putting order to the things you put inside that bag. And order in the way of saying, well, there's a zeroth element, a first element, a second element. That's what a list is. And we've been dealing with lists, and we just never called them that with arrays from day one. But we want to talk in terms of generically, how are we going to store those elements in the collection. Now, a list has order. A list has a zeroth element, a first element. It's guaranteed to have that order. And so here he decides, well, okay, now we tied down the description of this collection a little bit. We didn't really implement anything yet as to how. I know you want to start saying, well, why can't we just use an array? Well, there's good and bad things about arrays. There's another thing that I'm going to talk about in chapter 24, and that deals with linked lists. But anyway, let's talk a little bit more generically. Here he defines an interface called MyList of whatever, strings, dogs, whatever. And even this interface extends what is given to you in the JDK up here, java.util.collection. So what we're doing is coming up with an interface that's probably got more methods than what the generic collection does. Now, let me bring up what a collection looks like in the JDK. This is the interface collection that we're talking about, and you can read all that if you want. But if you take a look at the methods that you're supposed to implement if you had a class that has these methods, implements this interface, you have to have an add. You could think of this add as just being a way to dump things inside this bag. Add a whole bunch of things all at once. Clearing, contains. I mean, these are operations that make sense to a collection. Iterator is like an object that will go through this bag and return each element inside this bag guaranteed, but there's no particular order how it visits all those things. You can remove things from the bag. You can see that it all makes some sense. Okay, there's adding, removing, whatever. Now, with our list, what's missing from that thing that I just pulled away was there was no index here. Right? If you take a look at the add, here we're just adding something to this bag. It doesn't say that I want to add this as the fifth element or anything. That's where the list comes in, and this add method is gone. They went out of their way to come up with an add method that takes an index where I want the fifth element of this element to be a certain string or whatever. So we're adding to this collection the methods that we need to implement. We're not implementing anything here. This is just saying if you have a class that implements MyList, you have to implement those methods, or you can't create that object. Okay, so we want to be able to get the fifth element. We want to find the index of a particular value. Okay, that's a good searching technique. What's the last index of? Okay, there could be multiple Tonys inside this bag. Give me the last Tony. That kind of stuff. Remove the fifth element. Set a value for the fifth element. Now this is relatively new right here. See, the classic interface never really had implementations of code. And when they set out to design Java 8, they said, well, there's really no need to put that limitation to an interface. They're saying you still can't create a new MyList. You still can't do that because it's an interface. But there's nothing really wrong with creating a new or defining a method inside the interface. And so what happens here is, with this, this is the beauty of the override. You know you're doing something. You're overriding the definition of what's inside collection. Okay, and they're saying, well, you'll remember that collection had a method. This is the collection method, add. And what they're saying is, why don't we just, if you want to add generically to the end of the array, or I shouldn't say array, the end of this list, why don't we call this method right here that we're going to implement soon, okay, size returns the number of elements inside this bag, okay, add, pretend size was 10, add index 10, comma, whatever you want to add to the bag. That basically does the job of adding something to the end of the array, or I keep saying array, the end of the list, and return true. That, I guess it's supposed to return Boolean, because the original method said it returned Boolean. If it worked, it returns true. And there's no reason why it shouldn't work. You got gigabytes of storage in these modern computers, so that should just return true. Now, how do you know if you're empty? Well, if size is equal to 0. Great. So you've implemented that. See, what happens is you're taking the onus away from the person who implements the class. The person who implements the class doesn't have to implement these methods. Okay, remove. Okay, is I want to remove a particular element from there, and that's his implementation of remove. Now I'm going to give you a bunch of, he's implemented these methods here, and there's a couple of, for homework you're going to implement some of these elements here. I don't think it's these, but I think there's going to be some methods that you're going to implement that aren't these right here, but I think they're not these. I have to, well, anyway, you're going to be, for homework, you're going to implement some methods of this class. So let's take a look. Before we go on, though, take a look at the remove. Something should be hitting you right in the face, and that is remove. I would like to remove a particular object. Remember, when you're dealing with collections, when you're never storing simple data types or primitives like ints or doubles. You're never doing that. You always store objects inside these classes. An int will get automatically boxed into an integer class and then put inside the data structure. So what's going on here? Here's what's going on. I'm trying to locate. First off, you can only remove something if it's in there. All right. The way he's implemented this was, well, I believe remove will take care of this, but here's what he's saying. Find the item. If the item is in there, if you're trying to look for Tony and you want to get rid of Tony, and Tony's inside, If Tony's in there, then you can remove it past the index of what that of where Tony's located. But see, the problem is this could be this index of Tony is being called twice. You're not storing that. There could be a million elements in this bag. You're doing work twice. So why don't we do this? Why don't we say integer location? Let me say index. Index equals index of E. Okay, and if index is spelled right, if index is greater than or equal to 0, then hey, I guess you found it. So why don't we just pass that index to the remove method to get rid of it? So there you only call this index searching the technique once and not twice. At any rate, so what we're going to do now is say, well, this is generic. We haven't implemented any code. This is just, we're designing. Basically, an interface forces you to design what the class should do. Now we're going to worry about doing these particular methods. Okay? We're going to actually implement those. So we're going to do that in the next video. Take care.